Okay, exercise set 20.3. Looking at number one, it says factor it. And certainly there's no, it's not one way to do something. There's many ways to do something. Kind of looking at it. I'd rearrange it. I see it right now. What do I mean by that? I see m cubed plus n cubed. I took these two. I'm going to group those two. And then at the last, what I see over here, 2m squared n plus 2mn squared. I'll write that down. And then I would factor. And let me point out what I mean by that. The first two is the difference of perfect cubes. That's going to be m plus n. And then you're going to get m squared minus mn plus n squared. And the last two terms that I've grouped together, what comes out from that is 2mn. And what he left off with, let's take a look at it. The 2 came out. I got an m plus n now. Let me just check that. You get 2m squared and, yep, 2mn squared. Looking good. What do I get now? Well, I'm going to factor a common factor out from those two terms now. This is the common factor. And what do you get? You get m plus n times m squared minus mn plus n squared plus 2mn. All right? Let me write that down for you. You know, final answer, m plus n. This is a factorization, by the way. You get m squared plus mn plus n squared. All right? So I got this over here. All right? So the claim is that it's not bad to get it factored, and that's a factorization of the problem. So I want to point out, if you kind of read through this, it says, you know, rearrange by grouping. Well, we did that. If you decide to take the symmetric route, I mean route, all right? And that's true. I suggest you look for zeros. Clearly, m is not a factor because m equals 0 is not a root. Moving on, you may notice that the simple substitution m equals minus n produces 0, so m plus n is a factor, so it's just long division. I kind of see this as being a long-winded approach, but it does work. It does work out. And if you did that, and you might have done that, it's possible, this leads to the same thing. It leads to m plus n times this. M plus n times this would give you back this over here, which is the original problem. So it goes on to say, no matter how you proceed, all roads pretty much lead to the same conclusion. Now, granted, you may say to yourself, could you factor the m squared plus n plus n squared? Let's not worry about that now. We did get to the same answer, all right? But this is a quadratic in the end, and we'll talk about factoring those things a little bit more later on. As time goes on, you'll develop preferences, though. And my preferences is trying. I would say this, though, don't feel obligated to follow my exact work. But I'm really hopeful, mistakes aside, that we can agree in the end what the answer is. All right? Thank you.